So Unit 7, Part 2, Midterm Review. So first thing is percent composition. This kind of formula shows up again and again, pretty much anytime you want to calculate a percent, really. But when we're talking about percent composition, we're talking about of an element in a compound. So if I want to know what is the percent composition of calcium nitrate, right, that's asking, okay, what percentage of this calcium nitrate is calcium? What percentage is nitrogen? What percentage is oxygen? And we know that all the percentages add up to 100%, right, which is the whole. And so our formula is always our grams of what you're looking for divided by the grams of your total times 100, right? And so in solution, in Unit 9 solutions, what we're doing right now, we see this with our mass percent, right? When we're talking about the mass percent of a solute in a solution, okay? But here we're referring to the grams of an element, and our total, instead of being a solution, is just the total compound. And so the first thing you have to do, because they're not giving you any numbers, is you have to calculate molar mass. So if we list out our elements, calcium, nitrogen, and oxygen, I have 1 calcium, we have 2 nitrogens, and 6 oxygens. So we multiply by their mass on the periodic table, and we can see that calcium has a mass of 40.08, which gives a total of 40.08. Nitrogen is 14.01, so that gives us 28.02. And then 6 times 16 is, well, let's find out. 16 times 6 is 96. And then I add them all together, so plus 28.02 plus 40.08, and we get 164.10 grams. So what this means is that in 164.10 grams of calcium nitrate, 40.8 grams of them are calcium, 28.02 grams of them are nitrogen, and the 96 grams remaining is the oxygen. And so we could plug this into our formula and figure out, okay, what percentage is calcium? What percentage is nitrogen? What percentage is oxygen? And so the percent of calcium would be equal to 40.08 divided by our total, which is 164.10 times 100%, because anytime you have a percentage, you always multiply by 100, and you get 24.4% calcium. Okay, and we can do the same thing for nitrogen. We can say, okay, percent nitrogen is equal to 28.02 divided by 164.10 times 100%, and that gives us 17.1% nitrogen. Okay, and then our percent oxygen would be 96.00 divided by 164.10 times 100%, which equals, which we could really have just said 90 or 100 minus the other two percentages, because it should be the remaining, but it's 58.5%. And you can see that if you add up all three of our percentages, and this is percent oxygen, that they would all add up to 100, right? So we know that about our percentages. And so most of the time, the questions on your test or on the midterm will ask you for a specific element. They won't ask you to calculate all three percentages. They'll just want to know, what is the percent composition of calcium in calcium nitrate, or nitrogen in calcium nitrate. They'll ask for a specific element. So whatever element they're looking for, that's the one you solve for. Okay, and so the next thing that we kind of learned about was empirical and molecular formula, and how an empirical formula is the reduced or simplified formula, and the molecular formula is the actual formula of the compound that you're dealing with, right? So whatever you're working with. Now, sometimes your empirical and molecular formula are the same, but let me show you what it looks like if they're not. So for example, if you have the compound C2H6, I don't know what you're doing with it, but maybe you're doing some sort of experiment. The empirical formula, right, so this is our molecular because it's what we actually have, okay? If I simplify or reduce it, I can divide both 2 and 6 by 2, and that would give me CH3. Okay, this would be the empirical formula because it is reduced or simplified, okay? And multiple things could share the same empirical formula. Okay, if I have, for example, C4H12, that would also simplify down to CH3. So molecular formulas can share an empirical formula because it's a simplified or reduced version. It's the repeating pattern that keeps coming up. And so with empirical formula, there are a couple ways you can find it. So if you're given a percent composition, so you can figure out the empirical formula, and there's a little rhyme that goes with it. So each line of the rhyme, so percent to grams, grams to mole, divide by small, and multiply to whole, are the 4 steps in solving this problem. And so if we're going to solve this, then what you do is you take your percentages, and so this says what is the empirical formula, so we know we're looking for the simplified or reduced version of a compound that is 52.9% aluminum, so we have 52.9% aluminum, and it is 47.1% oxygen. Okay, so we've already got this going on. We just follow our steps, and what this will allow us to do is determine what are the subscripts that make up our empirical formula. So first thing is percent to grams. All you do is you change your percent sign to a G. So 42.9 grams of aluminum. And this would be 47.1 grams of oxygen. Now, if you're asking, Ms. Nichols, why can we do this? What you're doing is you're assuming that you have 100 grams of your sample. And if you have 100 grams of it, then 52.9% of 100 is just 52.9. So you're just making a general assumption. Okay, so that takes step number 1. Step number 2 is you change your grams to moles. Now, we know that changing grams to moles is what we did in our last video, and so we just set up a basic T-chart for each of these. And we follow our pattern. If I start with grams of aluminum, then grams of aluminum will go on the bottom, and we're changing it to moles of aluminum. And so that means we use our molar mass from the periodic table, which is 26.98 and 1 mole. And we do the same thing for oxygen, which has a mass of 16 grams of oxygen for every 1 mole of oxygen. And so when we do this, 52.9 divided by 26.98 gives us 1.96 moles, and 47.1 divided by 16.00 gives us 2.94 moles. Okay, so what we do is we then go to the next step, divide by small. Okay, so if we divide by small, that means we choose the smallest of our answers, so 1.96 and 2.94. The smallest is 1.96, and we divide both by 1.96. Okay, and what this gives us, this will give us 1, and this will give us 1.5. Okay, and so we see that 1 is a whole number, 1.5 is not a whole number. And since it ends in 0.5, we look over at our rhyme, and we know that if it ends in 0.5, that means I'm supposed to multiply it by 2 in order to get a whole number. If it ended in 0.3 or 0.6, we would multiply by 3. And for your test, we never really give you anything more complex than that. Could it be, 1.4 or 1.7 or 1.8? Yes. In real chemistry, it does. But we give you simplified problems because you're just learning the basics. So we multiply by 2 for all of them because we're trying to keep their ratios the same. So 1 times 2 is equal to 2, and 1.5 times 2 is equal to 3. And so what that means is that our empirical formula is Al2O3. We figured out our subscript. So that's how you do that. And then there's another kind of question where it says, what is the molecular formula? So in this time we're trying to find the molecular formula and not the empirical formula of a compound that has an empirical formula of CH4 and a molar mass of 48.15 grams per mole. Okay, so here's how I explain it. Imagine this box is your molecular formula, but you don't know what it looks like. You just know what one piece of it looks like. You know that this one piece is CH4, and then that piece repeats itself over and over and over again. Okay, you also know how much the whole thing weighs. The whole thing weighs 48.15 grams. Okay, well, if you can figure out how many times CH4 repeats itself, then you could figure out the formula. And so what you need to do is you need to be able to compare the weight or the mass of one piece and figure out how many times it can go into the whole. And so that means calculating the molar mass of CH4. So if we have carbon and hydrogen, we have 1 carbon and 4 hydrogens, and we multiply by their mass on the periodic table, and that will give us 4.04 for hydrogen. We add them all together and we get 16.05 grams per mole. We say, okay, if our one piece, CH4, weighs 16.05, what you do is you figure out how many times can it go into 48.15. You're going to do division. So we say 48.15 grams divided by 16.05 grams will give us 3. And so that 3 means that CH4 is repeated 3 times. And so that means our molecular formula is C3H12. We have 3 carbons and 12 hydrogens. And so that is pretty much what we learned in all of Unit 7. This is the end of Unit 7. Come back for the next unit, Unit 8.